Thank you guys for having me here. This is my first time doing a presentation and my first time at a Droid event, Droid convention. So thanks again for letting me here. I'm Ben. I'm from FrSky RC. A lot of you guys are familiar with our radio systems. Some of you aren't. So hopefully I'll be able to shed some more light on what our systems are capable of doing and what some other users are using our equipment for. So you guys may see some familiar photos. I apologize if I've used your photo without any photo credit. Just yell at me. Yeah. So I tried to do my best. I've been collecting photos of what you guys have been working on for like a year, and I forgot where I downloaded it. So
We'll allow it 3 seconds.
So again, my name is Ben Saraceno. I'm from FrSky, the USA branch. We do have our headquarters in China, but we have a distribution center in US that we deal with all of our accounts. My email address, all my contact information, and you can find me on Facebook, FrSky Ben. So, as you saw during the Kyber presentation, the two main box style systems that we have now are the X18 and the X20. These are dual band systems, so they run 2.4 gigahertz and 900 megahertz at the same time. And the benefit of that is that when you have any interference on 2.4, you're going to have interference on 2.4. It's not an if. But that 900 megahertz helps carry those packets through that noise floor and keep that signal with your Droid. Usually our systems are being used for things that are flying over the air, and we were trying to prevent them from going into the ground. So I don't know how well you can see it. I'm not going to touch on most of these points. Our systems are 24-channel systems by S-Bus. The 20 does not mean that it's a 20 channel, that just is the model number. So it's mostly hardware differences. The main difference between the X18 and the X20 is obviously the shape, the size of the screen. The X20 has a rotational sliders on the side. X18 has the linear sliders. The X20 has an additional slider up here in the front. This one has extra trims on the sides. So everything is pretty much programmable on our radios except for the navigation wheel and the system buttons. So this can be programmed to do anything. So can these 6-position buttons. They can be a 6-position button, momentary buttons, toggle on buttons, 2 3-position buttons, or basically, however you want them. The X18 has built-in memory, which doesn't really matter. X20 has an uses an SD card. One thing that I will point out with our systems is we have kind of like a few different versions of each system. So we have an X20 standard version, which has basically standard gimbals, plastic gimbals, 4-ball bearing. Then we have the S version. I'm always going to recommend S version for you guys because it has the built-in gyro sensors, which you saw during the Kyber presentation, that you can program to do, again, anything. In the case with the B2B mode, you're using control head. The HD version of the X20 has a built-in FPV feed, so you can actually get a camera feed onto the screen of the system, so you can know exactly where your droid is facing. If you're doing camera work, you can make sure that he's actually tracking the camera, or however you want to use that feature. I'll show that in a little bit more detail later. So I'm going to kind of rush through this because I'm hoping to cover everything that I have in my slides and then get into some more of the nitty-gritty. So our receivers are also dual band receivers. So they have the 900 megahertz antenna and the 2.4 antennas. The one you see on the right is the TDMX. That's this little guy here. This will give you your S-Bus output like you run into the Kyber control system, which I'll touch on later. Then we also have full-size receivers, like the TDR-18, that this will give you 18 servo outputs. Most of the time, you guys are doing all of your animations through either the maestros or the timer controllers or something else. So most of the time, you're only going to need just an S. So that's where this little comes in. But if you want to direct drive the servos or have controllable relay switches or any number of other things that you use your PWM channels for, that's where the big comes in. We also have receivers that are 10 channel and 6 channel, and we'll have some 12 channel receivers as well. Now our twin light system, that's the gaming sound controller system that was shown earlier. This one is dual 2.4. So instead of running 2.4 and 900, it's running 2.4 gigahertz and 2.4 gigahertz at the same time, two separate frequencies. So the benefit of having 2.4 over 900 is that your 2.4 has a lower latency, it's a faster control link than the 900, but the 900 has better penetration, more distance, so if you're driving behind a wall or something, it will penetrate through that wall, or if you have a metal shell for your droid, it may get that signal through that metal shell a little better. The difference between the S version and the non-S version on the twin light is not as drastic because the gimbals are the same between the two, but I still recommend the S version because the S version has the gyro. So it has built-in gyro, so you can basically control whatever you want to control. You can, most of the time, you're going to probably program it to control like a pan tilt for a head. So and that's what I'll show you about this little bit later. So we also have a servo line. So our servos come in all kinds of different sizes, micro servos, all the way up to like full-size servos. And I'll show you what this is all about in just a few minutes. So the servos are programmable, meaning that you can set the sweep, you can set the direction, you can set everything from like the pop friction and the E10s and all kinds of stuff to eliminate slop and the linkages. And you can actually get the telemetry feedback from the servos to know how much current they're drawing, what temperature they're running at, whether they're in a failed state or okay state. And so it kind of gives you an idea of if you have a servo that's binding up, causing an issue, overdrawing amps, you can know where to go in your system to figure that out.
Are they single rotation or?
Yes, they are single rotation, but you can program the sweep from 90 degrees, 120 degrees, and 180 degrees. So I'll show that. I'm going to kind of run through the slides, and then I'm going to go through some demos of everything all put there. So, this is probably one of the ones that you guys see the most, is our CNC gimbal sticking upgrades. There's a few radios here that may look familiar for you guys. There's a room here. The gimbal stick-ins can be installed to pretty much any system except for the twin light, depending on how mechanically inclined you are. The only difference is the threading. So you might be able to drill it out, re-tap the threading, and actually fit this little thing on if you're that determined. I haven't tried it yet, but I really like to do it because this system actually seems to be one of the preferred systems that the animatronics guys have been using because of the just compact form of it and just ease of use of using them on set or whatever. So that's my end goal. That's the idea. I'm gonna give it to you guys. The gimbal stick-ins come in kind of two variations. The ones you see that all have a button on top, but they also can be without a button. It just depends on exactly how you prefer your radio setup. All the systems, new systems run on Ethos operating system. So it's been completely kind of written for our new hardware. It's different than OpenTX in the sense that it's almost like Windows versus DOS. So the new system on Windows, on Ethos, is more user-friendly. Even if you don't really know like your way around, it's easy to navigate it. Whereas on OpenTX, you really have to know your way around that system. And OpenTX, we used to use our last generation radio system. So it's still a very powerful system, but it's much more, just takes much more work to get it in program. So we have a PC simulator for any of those. So I'm sorry, I installed the simulator to other user. So I'll just move on to the suite and I'll show the simulator later. So the suite allows you to update your ethos firmware on your radio. It's much more user friendly than the old OpenTX companion stuff where you have to like download firmware files and write them to the part of this. You just plug in the radio, it'll tell you if everything's up to date or out of date, and you click one button and it updates the system automatically. There are Bluetooth functionality with our radio systems that you can use for various purposes. One is for a Bluetooth head tracker input, so it's essentially another gyro system that you can connect by Bluetooth with the radios, and it acts as another input method. So you can most of the time people have used it as an actual head tracker, so the pan tilt system will track with their head. You could use it in the same manner to make your Droid, track with your head track, or you could use it just as like a joystick input to send inputs through the receiver to the keyboard or to the there's two kind of versions of the Bluetooth head tracker project. One of them runs off of the Arduino DSP. One of them runs off of this Seed Studio. It's basically a little $15 chip. And again, I'm going to kind of rush through this, and then I'm going to go back through and show some of the chips and everything out there, how they interact. Alternative input methods. So a lot of guys have been using the nunchucks to connect and interface with our systems. Basically, there's two ways to use the nunchuck. You could either wire it directly into the gimbals of the radio system, like we've got in this picture, or you could interface it to an Arduino, read the control, and then output it to a PPM signal, which you can feed into the trainer input on the radio systems. They make these little adapters that kind of plug into the bottom of the lead thing so that you don't really have to modify anything. You just plug it in, run a few cables, and then put some code on it. So there's a link here for a basic generic, like how to generate PPM stuff, or that you would be able to use essentially any pots or this is what the bottom right photo is. It's basically a custom machine joystick that is wired up with potentiometers going hardwired into the radio system, and they use that for puppetry animatronics at the Gentex and Creature Shop. And then they have little joysticks like this on eBay, essentially same idea. You just get your little the wires wired and right into the joysticks, or you could read it from an Arduino, feed it through PPM. There's a few different ways that you can interface with other input methods, either hardwiring them or working them through an Arduino PPM setup. Here's a few other examples where people have taken like flight control joysticks, like the USB joysticks that you use on flight simulators, and they basically wire directly into the pots, hook them up to Arduinos, and now they're running them into the trainer ports of the radio system to give joystick control input. And then Kyber controller from Trevor. And then also what some people are using are our standalone X8 HT modules. So the Ghostbusters RTV, it's like a little car. hopefully are familiar with Ghostbusters, you know, the spirit trap that gets the ghost. Well, on one of the last movies, they made a car version of it that they drive around, and what people are doing is using the XHT FrSky module and installing it with the old like Futaba transmitters, so that instead of running it on 72 megahertz, it's on a current 2.4 gigahertz system, but still has that old Futaba shell, just using the old gimbals. And so it's more of like a prop radio, but it's still functional in the sense that it's on current protocols and current RF systems. So, and then the last two radio systems here are a couple single stick radio systems that we OEM for one of our accounts. They use them to move around full-size airplanes and trailers for like RV trailers. So I'll show a picture of the robots that they actually use those systems with in just a couple more slides. So we can find multiple receivers for each of the models. As I said earlier, you can find up to 3 receivers having full telemetry feedback, meaning you can get like your battery voltages or RPM. We have a few different sensors, probably none of which really matter to you guys, like GPS sensor, airspeed sensor, variometer sensor for knowing the altitude of your droid. You know, in an airplane, it makes sense, but not so much for. So probably there you go. So once you get those rockets working, probably the most important sensor feedback that you guys are going to want from telemetry is battery voltage, because that's obviously important to know how much you have. You can also get up to 48 individual PWM outputs. So on the picture here, he's basically got 6 receivers hooked up. Each one is outputting 8 channels independently, and I'll show the video of that. Here's an example of that. So he's just showing the individual 48 channels, and when he flips the switch, you start from over here on 1, 11, all the way through that program. And then now you can see them actuating one by one with some programming logic that he's programmed into the radio. Basically looks like this. So he's using logic switches to control the mixer, and this is the logic switch setup. So essentially the edge function, it waits for the previous one, and then it just triggers each one consecutively. So that's this video demo. And I'll provide this slideshow so that you guys can go back, click on some of these video links, watch them, from start to finish. I'm just kind of getting the ideas to think. That's so the Kyber system. Most of this was covered during the last presentation, but I just wanted to touch on it again. So it's connected by a simple just S-bus connection. So on the picture on the right, you can see our X8R receiver with S-bus signal going into the Kyber controller. And I'm not sure what the other one is. I think it's a micro. Thank you. And then it's not picture that. It's okay. So hey, the photo on Facebook said it was practical. There's another picture basically of the kind of mixing that's involved with the Kyber system, so to control the dome motor, the drive, the turn, the Kyber pad, the volume as well. And then the Lewis scripts like Matt and Stefan just showed on the last presentation. The DF player is kind of a part of the Kyber system, but it is also a standalone component so that you can explore wiring that up on its own. It can be hit and miss, but again, it's basically decode the SFS signal, convert it to whatever you want it to do, play the next track, figure out which channel you want to play the next track, and you can generate some code to, fairly easily with Arduino to set it up however you want to control the DF player. So we have several companies using our equipment: Universal Pictures, Jim Henson Creature Shop. It's used on Discovery Channel for battle bots, and just all kinds of various just drone FPV filming and stuff. National Geographic, Twitter, complex area. Here are some examples of what people have been using their systems for. So there's a T1 Terminator. Dave is there. Is DJ Rex.
I did best.
Yeah. And on the right, what they have is actually a master brake cylinder from a car hooked up with our system that they use to do remote control crashes for movies. And then the bottom picture is Alan Robin. I met them at RC Toledo a few months ago. They've got the Wally and the Tarantula that they built. Bottom right is Masters Effects. They're using our equipment for some of their TV shows and movies that they do. That's Baby Best there. Again, Masters Effects up here on top left. That they're working on one of their DC Legends Universe episodes. The middle picture is Ominous. He's one of the battle bots, a 3-wheel battle bot that is using our equipment. Bottom right is Huge. They're using our QX7 to drive them around. And then the bottom left two, these are those single stick radio systems. They use them with these tracked vehicles. The one on the right will lift up either an airplane or a helicopter, full-size helicopter, to move it from hangar to hangar. And the one on the left is for picking up a trailer or moving a trailer around from camping site to camping site or whatever they do with it. One of the things I would like to explore is hacking some of the Galaxy's Edge droids and hopefully getting some S-Bus control or Bluetooth control with them. I've seen this project by Rusarian where he's actually interfaced with them directly, and I've talked to the Azure guys about maybe a mini Kyber controller where they can just plug in something. So we'll see what that is. Alright. Yeah. So let me show you guys a little bit of the system. Lighting in my house. There you go. Perfect. All right. So this is the X20 HD with the built-in FPV. Sorry, get this up here. Yes. Alright, one of you guys better with OBS.
Drag the camera to the page with the controls down and then trigger.
Yeah, it's just dragging it out. There's a way.
All the checkboxes there was
Oh.
That's good. You were good. Just think about
So basically here is our X20 HD system and you know, it's essentially sending the live feed from the camera here down. So, and obviously with such a small camera, you can pretty much mount that anywhere. So the idea is obviously, you know, that you can use this to make sure that your droid is looking at who it's talking to, or again, if you're doing film on set, you need to make sure that the droid is tracking with the camera. You can follow and keep that camera, you know, exactly in view as you're operating.
pretty low latency.
Super low latency, 3 millisecond lock latency. It has the lowest latency in the market, so it may not show here because I'm going to OBS, but yeah. So it's a little, so it's faster on the screen here, but by the time it goes to the webcam and then OBS into the HDMI, that would end up to there. It's a separate channel, it's on 5.8 gigahertz that it transmits, and then basically it's this video transmitter here. I have to keep the fan on it because this one's made for a drone, so it's meant to be like having constant airflow over it, but they have one that has a heat sink that you don't have to have this crazy compression that I've got going on.
I know it's not the drone, but for the droid, it'd be cool to have an audio feedback too. So you can hear somebody talking. Oh,
Yeah, so
that's good.
that's the X20H. Not much more to show on that. Most everything I have is on the switch here. So with the ecosystem, one of the things that you can do, and actually you can do this with OpenCS as well, but it's a little bit funkier. Is you can do sequencing. So sequencing, and essentially sequencing is generally used for landing gear on the airplanes where they want to open a gear door, drop the landing gear, and then close the gear door. But you guys might find sequencing useful for if you want to open up a cabinet, place some light sequence on a LCD or something, and then close the door or operate as hard or something like that. So. basically where you put the switch, the gear door opens, so then the gear comes down, and then the gear door closes. So you can
Maybe barely make that out.
That's when the gear door is down, is there feedback in your servo that's giving that information?
yes, I can look up the receiver.
Can you add like a haptic feedback when you know it's done?
Yeah, so you can program it to do haptic feedback, you can program it to have sound feedback, you can program it to do a few different things, with servo as well.
Yeah, so when it shuts, it vibrates, you know, it's supposed to.
And you can speaking of sound, you can update all custom sound settings, so whatever triggers you have, make up your own sounds.
Find the receiver. So that's a short example of how sequencing, obviously, sequencing is really powerful. Somebody posted a video a few months ago showing how they were using curves to control the sequencing, like advanced sequencing for animatronic programming. I've tried my best to find that video, but I cannot find it. So this is the best that I can. The sequencing uses two types of functions of the programming. So one is slow and one is delay. So the slow, as the name implies, it basically slows the output of the servo over a predefined period of time. With delay, it as it implies a delay. So I push the button, and 2 seconds later, you can see it toggle on channel 2. And then you can combine. So you can have a delay, and then, I don't have a delay, and then slow. So basically it waits 2 seconds, and then it's slow. It goes slow up, slow down. So that's, you can use the two functions independently to do different types of animatronic features, whatever you need. Because most of the time when you flip a panel open, you don't just want to flip open it. Maybe you want it to open slowly, or over like a half a second, so it's smooth and instead of just kind of flipping back and forth. This little programmable head was something that the Henson Studios graciously allowed me to use. And basically,
Use the mic.
Sorry, thank you. So this, yeah, I know I'm talking to you.
Use the mic for questions.
Yeah, so that, you know, you could put the camera on it. No. So the way I have the head programmed here is tilt, rotate left and right, rotate up and down, and also on the
Yeah, from the first.
So again,
Cool up.
basically left and right, up and down, and then also mixing in the throttle so you can have it looking down, and then also still have, you know, depending on what it says, or looking up. And then the gyro control. So this is now roll instead of left and right, so you can program them to have different, you know, actuating modes, and then also he doesn't quite like the gyro. Smooth out the gyro. But this is just a few examples of how you can program the head to move around, and basically the mix on that. So you have your left and right tilt. So you have your left and right tilt. The autofocus mode, so I apologize. The tilting up and down, and then the gyro goes. So when the gyro is active, you can see the gyro is lined up. You can do stuff like with our receivers that have gyros in them. You can basically make the head move around by just moving the receiver itself. So my idea with this was that essentially you have the gyro stabilized receiver mounted in the head to keep the head level as it's walking around for creatures that are able to do that. Maybe not humans, but just an idea. You know, I'm just trying to show off like a few different random that I should be messing with, you know, over the past few months. So that's the Bluetooth trainer. I don't have it so on it, but I can show how that looks. So this is a Bluetooth trainer that I showed earlier on the slide, the Arduino BLE Sense version. Basically, it just connects by Bluetooth with the system. And just like you saw the actuating the servos with the gyro there, it functions in much the same way where as you move this around, the head will also track with the movements from this 3 axes. So there's a few different ways to interface with the systems. Moving back in time to servos. So this is where I think a lot of you guys will like this demo because the servos are fully programmable. So, the new buying process for our system, I can show that right now. You hold this button to register it. And it will show up on the register. This is what autofocus of this camera is beyond that. So you register it and then find it. Outside. I'm setting this channel twice. And now I can discover the sensors. And the servo current, voltage, and temperature is all showing on the screen. And essentially what we can do now right now it's set to 120 degrees sweep, like I said, to 90 degrees sweep.
Do these speakers work on any text bus receiver or just a special receiver to do that technical?
So this is only with our equipment. So right now this is 90 degrees sweep.
Like an XAR?
No. X8R is too old. Now it's 180 degrees. You program it. You cannot program it in between. We've had requests for that, and I'm trying to get our the team to add both like any arbitrary angle programming as well as full 360 degree programming. Yeah.
I know you're rushing through this, but the next presenter has offered you more time, so you can take your time and slow down a little and not rush so much.
Okay.
So you're fine. Just keep going at your pace, and everyone seems to like what you're doing. So, and does anyone, when you want questions, just raise your hand. I'm going to hand you the microphone so we can hear your question.
I should be good on wrapping it up in about 5 minutes, because I only have a few more things to show. One is going to be the NFC switch. So the NFC switch is near field communication. It's not a magnetic switch. So they have them. They have switches in the past that work off of magnets, but this one's not magnetic. It uses NFC key, like on your phone. I'm not sure how you guys are all with the near field communication. So basically, it allows you to wirelessly turn off your receivers. So essentially, what you could have is this NFC switch mounted inside of your Droid up against the wall, depending on the wall thickness, and have everything plugged in and be able to turn them on and off with just
With the restraining bolt.
you can tell. So I think that's pretty much everything I have to show you guys. I probably forgot some
What's the average battery life of the transmitter?
I don't know an average, but generally we have them on it, and so we go to transmitting all day long, and we only have to charge them up like every couple of days, so I'd say like 10 to 12 hours. Depends, the answer is it depends on which protocol you're using and whether you're using the 2.4 and 900 at the same time, or just the 2.4, because if you're using both RF modules, it's going to drain more juice. And then also the power wattage output of the 900 that you select, because you can bump the power output up to 1 watt, and that's then drain more juice.
We do have another question.
What's the other cost of all these controllers?
So on the low end, we have different levels of radios with standard gimbals and upgrade gimbals, and standard features and upgrade features. On the low end, the gaming style radio with the standard features is $280, and then 360 with the gyro, the upgraded memory, better screen. On the higher end of things, we have our new X20 Pro, which is $995. So about $1,000, but that one has a metal shell. It has 3 RF modules in it. It supports text-to-speech functions, 8 gigabytes of internal memory. Some extra, it has the extra trims like the X18 has, as well as the middle slider like the X20 has. On average, the X20s that you guys have been using anywhere from 380 to 540 with the HD version. With the upgrade gimbals are usually about $18. So you save about $40 by going ahead and getting the radio with the upgrade gimbals already installed. The XE that I have over here. The thing about our radio systems, we have so many different options. So the XE, you can get it with the upgrade gimbal stick-ins, which are another $70. It has self-centering slider option, which is another $23, and a Bluetooth option, which is another $26. So depending on which add-ons you choose for the radios, you're looking anywhere from conservatively $500 to $700 maybe for a gaming system with like the stick-in upgrades, maybe a tray system like some of the other upgrades here have.
Any other questions? I have no money. I'm not ready to give it away.
But you have seasoning, is there, you just have it to the straightforward, you got it on, you have it off. Is it or is it just, how does that, could you like reverse the logic so that?
No, it's so
The
the
receiver's on, you just stay off.
no, it's I think it's based off the timer. So like if you leave it on there, it's yeah, it's gonna go back and forth. Last time I did it, it just stayed off.
If it's an NFC, could you use your phone that has NFC?
Yes, I have not figured that part out yet, but essentially when you bring up or Vivo,
There we go.
so see, you can use an NFC read tag that theoretically it says NFC switch. I haven't figured out my job yet. That's honestly a little bit beyond what I've messed with so far. But you should be able to go to the FrSky NFC key and then beam it, and then basically use your phone to turn on and off of this. Because I don't know if you saw what it wants to do. Any questions on the programs or anything, any of the menu systems or any of those operating systems?
Anyway, back
Any
here.
questions about integrations with the Kyber systems? It's honestly, with the cover stuff, it's pretty straightforward, and that's mostly what I see the value add for these guys is being able to interface with that hybrid system with the script widget. That to me, we've had people ask for that for a few years now, and we finally have it. They finally have it. So. Well, thank you guys.